Dear viewers, in one of our previous videos, we have explained the concept of simple moving average, where the simple moving average is a technique used to discount the short-term variation and understand the underlying long-term trend and pattern in the data. In that series, today we are going to understand what is called weighted moving average. So we have divided this video into three parts. The first part would be the conceptual understanding. Then I will be explaining about how to do this in Excel. And finally, we will close loop with what are the used cases of using weighted moving average. What are the advantages and disadvantages of using weighted moving average? Let's get into the video. As I was explaining in the introduction, your simple moving average explains or helps you to discount the short-term variation and understand the long-term trend. And the formula is designed in such a way that there is equal weightage for all the data points. If you are doing the simple moving average with n is equal to 3, your first data point, second data point and third data point, all of that will have equal weightage. That is how the formula is defined. However, the weighted moving average is a technique where you will be calculating moving average but by assigning different weights to data point within the chosen time period. For example, if you are doing the weighted moving average for n is equal to 3, you will not allocate equal weight for all the 3 data points. You will allocate different weight. And generally, when you are doing a time series analysis, less weightage is allocated to the older data point and more weightage is allocated to more recent data points. And by doing it, your weighted moving average is more responsive to recent changes. Your weighted moving average is more responsive to recent data points. That is the purpose by which we allocate a linear different weight for data points. So let's understand how the formula works. So if you see this formula, the formula says weighted moving average is nothing but the summation of product of weight and individual data point divided by summation of weights. As such, the formula might look little bit intimidating, but it's a very simple, straightforward formula. Let's understand this with the help of a practical example. So here I have taken some data points which are collected in chronological order. When we say chronological order, it is collected with respect to time. And we are going to calculate weighted moving average. And whenever we discuss the term weighted moving average, we need to define what is our n. N is nothing but your average is going to be calculated considering how many data points. And the second thing we need to define is weight. What is the weight you are going to allocate for those data points? And here if you see, I have allocated a linear weight of 0.5 to the first data point, 1 to the second data point and 1.5 to the third data point. So you can decide to allocate the weight the way you want, but since I am doing a time series analysis, I wanted to have a linear weight. So older data point takes less weight and new data point takes more weight. So that is the logic with which I have allocated this weight. Now if you want to understand how this formula get applied in this practical scenario, if you see here, the average of the first 3 data points are not calculated as it is. Instead, it is calculated as a weighted average. And what do we mean by weighted average? The first data point takes a weightage of 0.5. The second data point takes a weightage of 1 and the third data point takes a weightage of 1.5. And what does it mean? The first data point will be considered 10 multiplied by 0.5, which is 5. Second data point is 12 and the third data point is 14 multiplied by 1.5, which will make it 21. Right, so 21 plus 12 plus 5 divided by 0.5 plus 1 plus 1.5. So that is where you are getting the answer as 38 divided by 3. And the 38 divided by 3 will return a value of 12.67. So this is the weighted moving average for the first 3 data points. And when I repeat this formula for the next 3 data points, again here the first number is 12, second number is 14 and third number is 16. The corresponding weightage is allocated to each of this and then we are doing a product and then we are doing a summation. After that we are dividing it with total weight. So that becomes 44 by 3 and in this case it returns a value of 14.67. And when we repeat the same exercise for the next set of data points, now 14, 16, 18 is the order. 14 takes 0.5 weightage, 16 takes 1 as a weightage and 18 takes 1.5 and that results in 16.67. I am repeating this for the rest of the data point. As I do it, what you see in the far right of my screen, that is your weighted moving average considering n is equal to 3 and considering weightage equal to 0.5, 1 and 1.5. Now let's move to Excel and understand how this same concept is explained or can be done in Excel. So here I have the same set of data points. So I'm going to apply the formula. So is equal to, so the formula here need to be entered little bit carefully. The reason is when I say is equal to, this is my first data point. And as per the weighted average formula or weighted moving average formula, data point 1 multiplied by the corresponding weight plus data point 2, so we open brackets, data point 2 multiplied by the corresponding weightage, close brackets, plus open brackets, data point 3 multiplied by the corresponding weightage. Now what we have done, we have multiplied the weightage with individual data points, and now we are going to define this entire string as a numerator. So I'm going to add a bracket in the beginning and add a bracket at the end. So this becomes my numerator, and then I divide it with 3. 3 becomes my denominator. Why 3? Because here my n is equal to 3. I have taken 3 data points. Now I can copy paste this formula, but it will not give you the right result. Why it will not give you the right result? Because if you double click this formula, like how the numbers are moving by one cell, the weightage also moves by one cell. So in order to avoid this, what we do, we come to the formula section where we have given the weightage, we are freezing that particular cell with a dollar sign. So many of you who use Excel frequently will know, if you put a dollar sign in the beginning of the alphabet and in the beginning of the number, that cell will get freezed and you can copy paste the formula and the cell will not move. So if you put a dollar symbol before the alphabet and before the number of any cell, that cell will be freezed. So now if I copy and paste this, you will, if you double click, you will understand only the data point has moved by one cell, the weightage still remains the same. So what you see here in column D is the weighted moving average considering n is equal to 3 and considering weightage equal to 0.5, 1 and 1.5. Now what I want to do is, I just want to give you a comparison. So I just calculate simple moving average, which is calculated by average first 3 data points, and then I can copy paste this formula for the rest of the data points or rest of the cells. I will get the moving average, simple moving average, no weightage assigned. So the yellow color exclamation symbol is telling you there is inconsistency in the formula. So I say ignore error. So you get this data. Now if you try to draw a trend chart out of this, so you can select this, you can click on insert, you can click on a line chart, and if you try to draw a trend chart out of it, what you see here, the blue color line that you see here is for the actual data point, which has little bit of fluctuation, whereas the orange color that you see here is for weighted moving average, and the gray color that you see here is for simple moving average. So hope this calculation part is useful for you to do this when you want to do it in Excel. Now we will come to the last part of the video where we will understand the usage of weighted moving average and the advantages and disadvantages of using weighted moving average. Let's understand that. So when you want to understand the use case for weighted moving average, it is being used in different industries, like in organizations where you are monitoring quality control. This particular method is used to monitor your metrics. It could be defect rate, it could be productivity, giving more importance to recent data. So you can allocate weightage, and based on that you can track this, so it will give you more weightage for recent data. Similarly, in volume forecasting, demand forecasting, financial analysis, inventory management, in all these places there is a usage of moving average chart. But instead of using a simple moving average, if you use a weighted moving average, you can assign different weights considering where you need to give more emphasis, which particular data need to be considered more seriously. Considering that, you can assign weight. That is how the usage of weighted moving average chart works. Now we'll understand the advantages and disadvantages. And advantage of using a weighted moving average is, as I was explaining right from the beginning, the analyst, the person who is analyzing, has a option to consider giving different weights, which data is more important, which data is less important. That can be decided by the analyst, and that is what the big difference between weighted moving average and simple moving average. So that is very important. And by allocating weight, we can make this chart, or we can make this calculation more responsive to recent changes by allocating more weight for recent data. So that's the advantage. Whereas from a disadvantage perspective, the calculation is not as simple as simple moving average. We need to be a little bit careful when we are doing it. And sometimes if the weightage is not given properly, we may give over importance to some data points but not really considering the long term trend. So that is a flip side of using a weighted moving average. So that is why allocation of weight becomes an important parameter. So by allocating proper weight, we will be able to analyze the data in a correct way. So friends, in our next video, I will be explaining about exponential moving average, one of the most important topics. Simple moving average, weighted moving average is also important, but exponential moving average is something which is very commonly used in time series analysis. So that is the next video that I'm planning to upload. So thanks for your time. Thanks for watching this video. For more video on statistical analysis, time series analysis, videos on quality management concepts, videos on tools and techniques of using Minitab, for all this, I would request you to kindly subscribe and follow our channel. Thanks for your time. See you in another video.